We have studied about different types of reactions of the alkanes. Next, one type of reaction is left, that is called pyrolysis. So, pyrolysis is the heating of alkanes at very high temperatures in absence of any other oxidant or any other reagent. When we heat alkanes in very high temperatures, then they undergo fragmentation. That is, they form some lower alkanes or alkenes. This reaction is called pyrolysis. So, next is pyrolysis. So, pyrolysis is the process by which a compound undergoes thermal degradation into smaller fragments without oxygen or any other reagents. Okay, this is pyrolysis. So, by pyrolysis, higher alkanes are converted to lowered alkanes or alkenes on heating at high temperatures. Okay. So, let's consider C6H14. This is hexane. Okay. When we heat this at say 773 Kelvin, that is around 500 degrees Celsius. So, we are not giving any other type of reagent here, only heating alkane. So, it has many possibilities. So, first, one hydrogen can be eliminated from here, one molecule of hydrogen. So, it will form C6H12 plus H2. This is hexene. Another can be methane. Okay. When methane is liberated, see CH4 is liberated. So, what is left in hexane? C5H10 is left. So, from here we can eliminate ethene. So, this is methane, this is ethene, then C3H6, this is propene. Then again we can have C2H6 plus C4H8. So, C2H6 is ethane and C4H8 is butene. Okay. So, these can be various possibilities. So, this was pyrolysis of hexane. Now, pyrolysis is considered to follow free radical mechanism. Okay. So, actually pyrolysis is also industrially used for the preparation of oil gas or petrol gas from kerosene oil or petrol. Okay. These conversions are done through pyrolysis. One example is C12H26, that is dodecan. This is a higher alkane. When it is treated in presence of platinum or palladium or nickel catalyst at 973 Kelvin, it gives C7H16, that is heptane, plus C5H10, that is pentene, and some other products. So, this was the pyrolysis of alkanes. So, in the previous lecture when we were discussing about aromatization, one more reaction I would like to add here, that is if we take heptane, okay, and we do the same reaction under similar conditions, then in hexane we had exactly 6 atoms, so we were getting benzene, but in heptane we have 7 atoms. So, with benzene we will get one methyl group here. This is called toluene. Okay. So, when we are doing the aromatization reaction, 6 atoms form benzene and other extra methyl groups, other extra carbons will be added to benzene in the form of methyl groups. Like if we take octane, then it can form methyl groups in 2 positions of benzene like this, or it can also add one ethyl group. So, this I wanted to add in aromatization. So, now with pyrolysis we have completed all the reactions of alkanes in general. So, we have completed the part of alkanes. Now, we will move on to alkenes. Alkenes are the compounds, alkenes are the hydrocarbons which contain at least one carbon-carbon double bond. So, within alkenes we will study about how the bonds are formed in alkenes, their nomenclature, isomerism of alkenes, their preparation, reactions, etc. So, let us start alkenes. Alkenes. Okay. So, alkenes are unsaturated hydrocarbons having at least one C double bond C. Okay. So, alkanes were saturated because alkanes had only single bonds, but alkenes are called unsaturated because they have at least one double bond. So, let us talk about the general formula of alkenes. Okay. For naming alkanes, we used this general formula. CnH2n plus 2. So in alkanes there were only single bonds. In alkenes there can be one double bond. So double bond means what is the valency of carbon? Valency of carbon was 4. So in alkanes it was written like this, the 4 valencies were covered. In alkenes what happens? One double bond is there. So 2 bonds are completed here only. So more 2 bonds are left for each carbon. Like this. So from each carbon, one hydrogen has been reduced. So the general formula of alkenes, that is only the alkenes having one double bond, they will have alkenes with one carbon-carbon double bond will have 2 hydrogens less than the corresponding alkane, right? So for alkenes we write the general formula as CnH2n, okay. CnH2n plus 2 was for alkanes, we remove 2 hydrogen and we get CnH2n. This is alkenes. Now for naming alkanes, we used ANE at the end, that is N, ethane, propane, butane, etc. For alkenes, we will use ENE, that is in at the end, like propene, butene, pentene, etc. So the smallest alkene or smallest stable alkene is C2H4. See, if 2 is N, then 2N equal to 4, right? 2 into 2. So let's say, see the name of the alkenes. The first one is N equal to 2. So C2H4, this is called ethene. How is it written? CH2 double bond CH2, okay. Next, N equal to 3, that is C3H6. This is called propene. So one double bond, right? So this one will be CH3, CH, and this is CH2. So this is propene. N equal to 4. So C4, 2N will be 8. So C4H8. This is called butene. So this is like this, okay. Now butene can be of 2 types. One is this, and now the double bond so these can be considered as the positional isomers of each other, because the position of the double bonds are changing. So these two are positional isomers. One can be called but1ene or 1-butene, okay, and another can be called but-2-ene or 2-butene. Next, if N equal to 5, then C5H10, this is pentene. Okay. So, this is pentene. Now, here also the positions can change. This one is pent-1-ene and the next one will be pent-2-ene. Okay. If we change position of the double bond again, then the same isomers will be formed. So, this was the nomenclature of alkenes. Alkenes are also called olefins. Okay. Olefins means oil forming. Why? Because when ethene was reacted with chlorine, it forms some oily liquid. This was first discovered, that is why alkenes are also called olefins. In many questions, you may see olefins written in place of alkenes. Okay. Now, we will study about the carbon-carbon double bond. Structure of C double bond C. So, in alkanes, carbon was sp3 hybridized. In alkenes, the carbon having double bond will be sp2 hybridized. Okay. So, the configuration of carbon is like this. In the valence shell of carbon, it is like this. So, if it forms sp2 hybridization, then one p orbital will be left. So, there will be 3 sp2 orbitals. sp2 means these, right. So, there will be 3 sp2 orbitals, one electron will come here and there will be one p orbital. So, 3 sp2 orbitals will form 3 sigma bonds and one p orbital will form one pi bond. So, what are the sigma bonds? So, there will be 3 sigma bonds. So, let us say this is one carbon, it has 3 sp2 orbitals. Okay. So, 2 sp2 orbitals will form sigma bonds with 1s orbitals of 2 hydrogens, and the another sp2 orbital will form a sigma bond by head-on overlap with the sp2 orbital of another carbon. Okay. So, what are the 3 sigma bonds? There are 2 CH bonds sp2 and 1s, and one carbon-carbon bond between two sp2 orbitals. So, this is the sigma bond. Now, pi bond. So, sigma bond was head-on overlap. Okay. In pi bond, what happens? There was one p orbital left. So, the carbons have already formed these bonds. Okay. Now, one p orbital is left in each carbon. So, they will form bonds by sideways overlap. What is the sideways overlap? Sideways overlap is like this. This is called sideways or lateral overlap. So, one pi bond is formed like this. So, one was sigma and one is pi. So, carbon-carbon double bond contains one sigma and one pi. Now, the pi bonds actually form electron clouds. The electrons of the pi bond exists in the form of electron clouds. So, this was the bond formation in alkenes. We will discuss further about the bond lengths, bond angle and bond strengths in the next lecture. Thank you.